Okay, AP Chemistry topic 1.6, which is photoelectron spectroscopy, which we usually call PES. So PES is an application of the photoelectric effect, which just says that you can make electrons leave an elemental sample if you shine a light on them at the same energy of the electrons. So what we do is we shine a light on an elemental sample. Electrons at that energy, if we hit the right one, will leave, and then we can quantify the number of electrons that are leaving relative to each other at particular energies, and then we can graph that. So that's what we're going to look at. So first of all, what information can we get from a PES? So we can tell the energy levels that are present in an atom, so in the electron cloud. We can get more information than just that. We can look at the subshells, and we can also tell how many electrons are in each subshell. And then from that information, we can pull it all together to get electron configuration. So let's look at a graph, and I actually want to label this for you as we talk through. So if we're going to be thinking about the energy levels that are present in an atom, and then this is my hand-drawn graph, you would get a better one on the AP Chemistry exam. But I kind of want to show you clusters, and that's what my hand sketch is not really great here. So we've got this one peak here, and then I didn't do a fantastic job of spreading these out, so I'm sorry, but there's another cluster of peaks here, and then we've also got a cluster of peaks over here. So this is your first energy level. Now another thing I want to point out to you is that this axis, the x-axis, is flipped of what we normally see. So your high value is over here near your origin for the y, and then we get smaller and smaller and smaller. And I also want to point out to you that this is a logarithmic scale. So if we look at, these are supposed to be evenly spaced amounts here, this is 1,000, and then it goes to 100, and then it goes to 10. Okay, so that's a logarithmic scale. So this is your first energy level, and then these two groups of peaks here would be your second energy level, and then this is your third. Okay, so then the height of the peak tells you the number of electrons that's present in each amount of energy. So then this would be your 1s, because that's what comes first, and then there's 2 electrons in there. So then we know that all other energies at the, peaks at the same height have the same number of electrons. So then this is going to be your 2s2. And this is going to be, your 2p2. These sticky notes, 2p6. These sticky notes are less sticky. They're staying put. Okay, so then here we're coming back down, and we've got your 3s2. And so then this would be your 3p2. So then we can write our electron configuration. So this is 1s2, 2s2, 2p6, 3s2, 3p2. Okay, and so this right here, this is silicon. So here, I can show you on the periodic table. So 1s1, 2, 2s1, 2, 2p6, 3s2, 3p1, 2. So there you go. That is silicon, especially if you know that this is a neutral atom. So we had silicon there, and you'll notice that I've actually drawn a new set of peaks, and I tried to draw them in a different color so you could see. So this is actually the next element over, which is phosphorus. So that only added 1 more electron, and so you might only expect your 3p peak to change, and it did. It went up by 1, so that's 3p3. But please also notice that our peaks shifted closer to the y-axis, so there's more energy required. And why is that? That is because silicon has 14 protons in its nucleus, while phosphorus has 15. But the last electron is going into the same distance, right? So all of these things experience a shift. They're being drawn closer to the nucleus because there is a greater charge on the nucleus for phosphorus than there was for silicon. So this also shows us evidence of Coulomb's law and its impact on electronic structure. So there you go. That's pretty much what you need to know for PES. So you should be able to, I'm going to pull this list back out right here. You should be able to look at a PES, think about how many energy levels are there and the subshells and the number of electrons in each subshell to write an electron configuration. And then they have also asked why you see a shift like this. And so then that is due to a change in the number of protons in the nucleus. So that's all about PES.